All right, let's look at this relationship for angular size. And I'm really focusing on the problem that has to do with Betelgeuse. But we have to talk a little bit about this relationship, which we're going to use to solve the problem first. So, the angular size of an object, that's its size when we measure it as an angle, is 57.3 degrees times the ratio of the actual size of the object over the distance. That's how far away it is. So we have to be careful about the units because actually a lot of the difficulty with this problem is the units and being careful with them. So notice that this number here is in degrees, and that means that we expect the angular size, our answer, to also be expressed in degrees. That is only going to happen if we express the actual size and the distance with the same units, because then the units will cancel out. And that's one of the things that we have to be careful of. In the problem, we're told that the distance to Betelgeuse is 427 light years. Well, that's because Betelgeuse is very far away, and we use light years because that's a large unit of distance. However, we wouldn't want to measure the actual size in light years, so we're going to convert light years to kilometers. If we look in the book, we find that we're told that 1 light year is 9.46 trillion kilometers. If we want to put that in scientific notation, it's 10 to the 12th as trillions. That's because a million is 10 to the 6th, a billion is 10 to the 9th, a trillion is 10 to the 12th. Notice we're going up by 3. The power goes up by 3 for every one. If I do that, then I find that the distance to Betelgeuse measured in kilometers is 4.039 times 10 to the 15th kilometers. All right, so that's what I'm going to use for the distance. Now, I'm also told that the angular size of Betelgeuse is in 0.044 arc seconds. Now, an arc second is a very small division of a degree. What we find is that in 1 degree, there are 60 arc minutes, and in 1 arc minute, there are 60 arc seconds. So it's like dividing the degree into really small portions, and that simply really mimics the idea that when you look at Betelgeuse in the sky, it looks like a pinpoint of light. It hardly even seems like it covers a substantial angle. Now, I'd like to change this to degrees because the 57.3 right here is in degrees, and so I want to be consistent. Well, we have to be, otherwise we're going to have a big problem. So we're going to use a unit conversion, and so we'll say there are 60 arc seconds in 1 arc minute, and then there are 60 arc minutes in 1 arc second. Notice my units are going to cancel out, and sorry, I've got this all. So this should be 1 degree. Sorry about that. So our answer for angular size is that it's also in degrees, 1.222 times 10 to the minus 5th degrees. Notice it's a much smaller number, but that's because degrees is a bigger unit than the arc seconds are. All right, so now I'm going to rearrange this expression up above, so that I could solve for the actual size. If we rearrange this, we would find that it would be equal to the angular size times the distance divided by 57.3 degrees. Now notice the angular size is in degrees, the distance is in kilometers, but the denominator is in degrees too, so those units are going to cancel out. My answer is going to be in kilometers. And I get 8.615 times 10 to the 8th kilometers is the actual size of the Betelgeuse, and that's actually the diameter of Betelgeuse. All right, now let's talk about the second part of that problem. In the second part of the problem, they want you to compare it to the sun. And so you have the diameter of Betelgeuse, which is 8.615 times 10 to the 8th kilometers. If we look up the sun, in the back of the book we find the radius of the sun is 695,000 kilometers. So that means the diameter of the sun is twice that, which is going to be 1,390,000 kilometers. So the way that we could compare it is we could put the diameter of Betelgeuse over the diameter of the sun. And so we would put 8.615 times 10 to the 8th kilometers over 1,390,000 kilometers. And that should give us an answer, I forget, a ratio of around 600, maybe? But whatever this number is, you could say that Betelgeuse is that number times bigger than the sun. And that's what they mean by comparing it. I hope that helps.